You see? All right. So the way that this is going to work, please. All right. We have a. I can't show you, but you guys can see in your notes. There's a table of words there. We're just going to match the word to the definition and then draw a picture and talk about some notation if it applies. All right. So what do you guys think indicates a location but has no size? A point. Now this is interesting because when we draw points, we physically see them, right? When we do that, that's our best representation of a point, but that's actually technically a dot. A point actually can't be seen. So the best way that we can represent a point is with a dot, which is the visual representation. Because the official definition of a point is that it has no size. So obviously you can't see it. The way that we use notation for a point, see there's the technology glitch. I'm just going to call that point P. The way that you guys name or use notation for a point is one letter. Whatever they've labeled the point in the picture or line or segment or whatever, that's how you would name it. You just use a letter. Right. What is a straight path that extends in two opposite directions forever and contains infinite lines? A line. Okay. How would I draw that? You would draw little arrows on the end, tells you you're going on forever. Now, when you guys are working with lines, you want to label the start and end. All right, you can use any letters you want. I'm going to stick with the AB pattern here. That's how you would label a picture. What if I wanted to name this? If I wanted to call it line AB, there has to be a little notation that goes above the letters to indicate that it's a line. Yes. Yeah, you draw a teeny little line like this with two arrows. That's your indication. That's your notation that it's line AB. Okay. What is a flat surface that extends forever and contains infinitely many lines? That is a plane. Now, a plane is in 3D, so it's going to be really difficult to draw and understand drawings of planes. But the best that I can do is a little like slanted rectangle thing. All right. A plane has to have. I'm sorry, this is going to be a little bit squished. ABC. A plane has to have at least 3 points. A line has to have at least 2. A plane has to have at least 3. How do you think I would name the plane the same way that I did for the line? Anybody have an idea? ABC. There's no extra symbol. You just write 3 letters and that's good. You could also use 4 letters if they give you 4 points, but the minimum number of letters you need for the name is 3. All right, a part of a line that is contained between 2 set endpoints. A part of a line that is contained between 2 endpoints. A line segment, or just segment. You don't have to include the line part. It's kind of understood that it's a segment of a line. All right, so a line segment, you have your 2 endpoints like this, A and B. How do you think the notation would be different for my line segment as opposed to a line? You don't have arrows. So this is still a B, but to indicate that it's a segment, you just use a flat line without arrows. Okay, so important difference between the line and the line segment. An aside question, can you find the length of a line? No. Can you find the length of a line segment?
Yes.
Yes. Are you going to let me scroll? Okay, good. All right, a part of a line that has 1 endpoint and continues forever in one direction. That's a ray. Okay? I'm going to draw 2 of them. One going to the right, one going to the left, because the way that we name rays is a little bit tricky. I'm going to draw 2. And then I'm going to call this one AB, and I'm also going to call this one AB. But do you think I'm going to name them the same way?
No.
No. Does anybody know how you would name this top one? What letter would I start with? The A. So I would have AB, and then the symbol for array is basically a little ray above AB. Now how would I name the one on the bottom? BA. And it still points to the right. So So what's important about naming rays is that you always start with the end point, right? Regardless of whether it's pointing to the left or the right, you always start with the end point, and the notation is always pointing to the right. Okay? All right, what verb means to divide into two congruent parts? Bisect. Sorry for my weird handwriting. It's the best I can do to keep it from messing up. All right, so bisect means to cut into two parts. There's really no picture you can do for that. The verb. Moving on. A point, ray, line, or segment that is doing the dividing of a line segment into two congruent parts. It's a segment bisector. Segment bisector. Now, I don't really know how you guys want to draw this. That could be a line, that could be a ray, that could be a segment, could be just a point, but as long as it divides it in half, have you guys ever seen this before, those little hash marks? Those little hash marks mean that those two segments are of equal length. So when something is bisected, you have those two little halves are the same. Great, two rays that share the same endpoint but go in opposite directions and yet still form a line. Those are opposite rays. Okay, so the way that we're going to draw this, right, we have one ray going this way. How would I draw the opposite ray? Do I pick a new starting point? No, same starting point, just goes in the opposite direction. Okay, so I'm going to call this A and then B and then C. So in this diagram, what are the opposite rays? I'm going to write them down. Okay, BA and BC. Notice how they both have the same endpoint, B, but they're going in opposite directions, but you have to name them correctly. The B comes first, and then the A and C come second for both of the names. Does that make sense? Okay. Points that lie on the same line. Collinear. Is that two L's? Is that right? Okay. Collinear. Which means they're on the same line. So if you have a line like this, and you want them to be collinear, dot, 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 however many you want, those are all collinear. If I put a point here, would that be collinear? No. No. Okay, we don't want that one. They all have to be on the same line. All right, what about points and lines that lie on the same plane? Coplanar. All right, this is going to be hard to draw. You guys have like a plane. We have points that are on the same plane, lines that are on the same plane. You can draw that however you want. It's really complicated because it's 3D. But imagine, I don't have a piece of paper handy, but imagine a plane is like a piece of paper. If you were to draw a bunch of lines on that one piece of paper, those would all be coplanar because they're on the same piece of paper. But if you had two pieces of paper where you drew a line here, and then you had another piece of paper where you drew a line there, those are not coplanar because they're on different planes. Does that make sense? All right. The figure created by two rays that share an endpoint, and that shared endpoint is called the vertex. What has a vertex? An angle. The official, no. Hold on. Yep, all right. This is what happened last time. Give me 1 second. The A kind of took a turn there. I have no idea why it is not letting me erase now, but okay. All right. The only way I know how to do this is close and reopen. So give me 1 second. Anywho, I'm sure you guys know how to right angle and then draw one. So if you could do that for me in your notes. I wonder if that's still records if I close it. All right, let's see if it'll work now. All right, so what's interesting about the angle is the definition there. Go away. Weird day. All right. Angle. All right, so an angle is technically two rays smushed together. That's the official definition of an angle. You can draw any type of angle you want there. We're going to talk about 4 specific types of angles in just a second. But you guys do need to remember that the pointy part of the angle is called a vertex, because I refer to it as vertex often. There are other things called vertex, like if you guys have a square, if you think about a rectangle or a square, any corner where 2 segments or rays meet is technically called a vertex. So keep that in mind. All right, what kind of an angle has a measure less than 90? Acute. You guys can draw whatever type of acute angle you want. Right, anything from 1 degree to 89 degrees and anywhere in between, decimals included, that's acute. All right, an angle that has a measure more than 90 but less than 180. Obtuse. All right, again, you can draw whatever you want for the obtuse. What about an angle whose measure is exactly equal to 90? Right. Good. Now, whoopsie. No. No. Something specific to note about a right angle is that it's really dangerous to make assumptions. If I draw this, can I say for certain that that is a 90-degree angle? No. No. It could be 90.1 degrees. It could be 89 degrees. It could be 91 degrees. What's the only way you can definitively tell that is a 90? Little box. So when you guys are working in diagrams, where you guys have a bunch of lines and segments and all sorts of stuff going everywhere, and you're trying to figure out measures of angles, you cannot assume that something that looks 90 is 90 unless you have that little box there. It's a very dangerous assumption to make. Right, what do you call an angle that has exactly 180 degrees straight? Oops, that's an I, that is T. Alright, I don't know why they technically have this definition, because instead of calling it a straight angle, we'd rather call it a line. So we don't really use straight angles that often. Alright, on the next page, we're going to practice 2 different sides of a coin. I'm going to give you the name and notation for something, and I want you to tell me what that something is. And then I'm going to ask you to look at this picture and then write down the appropriate name and notation for things I'm describing. Okay? So over here, I have AB with this little thing over top of it. What is that talking about?
Line segment.
A line segment, or I'm just going to use the word segment. You don't have to say line every time. Segment AB. Or line segment AB if you want to write the whole thing. So segment AB. What about this next one? That's a ray. Ray DF. All right, this one that's highlighted is a little bit different. We didn't specifically talk about it on the previous page. This one has 2 letters, but nothing above it.
Point.
No, point is 1 letter. Nope, a point has to be at least 3 letters. When you guys have 2 letters, it's referring to a segment, but something specific about the segment. It's measure. Write this down. Measure of segment XY. Should have made the box a little bit bigger. when you guys see two letters, they are referring to a segment, but if they take the little segment piece off, then they're saying, I want you to find the measure of x, y. So mathematicians are lazy. They use symbols and stuff to represent words all the time. So instead of, in a question, instead of writing find the measure of segment x, y, and I just say find x, y. Find x, y. You guys need to understand that means find the measure of x, y. Right? So I'm sorry I kind of screwed it like that. But that's why they have that notation, just to cut out two words. But whatever. All right, what about the next one? Line QR. Next one? Point W. Plane. ALM. Then what about the last one? What do you think that is? Measure of. That's how they write measure of angle. So if they want you to find the measure of a segment, they just take the little segment piece off. If they want you to find the measure of an angle, they stick a little M there. We're going to talk about how to name angles 3 different ways in a second. But I want you guys to do on your own now. Is looking at this picture, which I can understand is hard to visualize. The gray is a plane, and this line right here is cutting through it like this. It's hard to draw something 3D, but this is a plane that has a line going through it like this. I want you guys to fill out as many of these as you can on your own. You can help each other ask me questions, but I need you to use appropriate names and notations in that side of the chart. Okay, so go ahead and take a few minutes to fill that. There are multiple different answers. Okay?
How do I know? So, line segment here, right? Here. Here. So, that's 3. That's my line. G3. Yeah.
Is it this way? Line is D.
Line is line E.
Line H. Isn't it H?
Actually, yeah, for some I still don't understand. Yeah, I don't have the one for the plane. That's also so like it says 3 points.
3 points that are on.
What hopefully?
You can do H. No, then you.
So 2 points.
Yeah, that's fine.
No, because D is on the middle.
My point was the line.
Yeah, that's why I have to say D.
The point has that. Just like.
Name the plane. The point is the sound. Oh.
I'm literally gonna go to the what's this stupid one thing goes to I'm asking. Yeah, okay. Let me ask her where
But I can still have the point on the That's not Oh no! I need
Alright, let's come back together. Alright, so you guys need to know what you need in order to name something, and you also need to know the appropriate notation for that. So in order to name a plane, what do you need? You need 3 points, all on the same plane. So what's the one point that I can't use? H. Because like I said, it's like a line kind of going through it like this, so H is floating above it. So you get to pick any 3 of those and write them in whatever order you want. Okay, so for example, second, G, D, E. We've done D, E, F, F, E, D, F, G, E, whatever order you want. Right? You need at least 3. You could have used all 4 if you had wanted to, but you need at least 3 points to name a plane. Alright, what does collinear mean? On the same line. So look at your picture. We have a couple of lines here. So just pick 2 points that are on the same line. E and F. D and F, E and F, E and H, E and F, that's fine too. You guys need to make sure that you separate them with commas. You would be incorrect if you guys wrote E, F next to each other. Points are 1 letter each, and if you're writing a list of them, you need commas in between. Okay? So a point is 1 letter, and if you're doing multiples of them, you need a comma in between. Alright. What are 3 points that are coplanar? G, E, F is an example. Again, separated with commas. You could have said D, E, F, D, E, G, whatever you want, but they do need to be separated by commas. Alright, what is an array with initial point D? Initial point meaning that's where it starts. D, F. Do you just write D, F?
No, you put the line, the array on.
Use the array notation. Is there another answer? You could have put DE. You could have also chosen DE. As long as the point, listen, as long as the point is along the path of the array, you can use that to name it. You don't have to use the very last point. You can use any point that's along the expanse of the array, because there are infinitely many points. Alright, where's the line in here?
Yeah.
All right, if you chose DF again, how do you distinguish this as a line? Double arrows. So you can still use DF, just to distinguish it from the ray, you use the other notation. There are other lines. You could have said DE, you could have said HE. Would HE and EH be the same for a line? Yes, for a line, HE and EH would be the same. Would that be true for a ray? No. So there's all these little details you guys need to pay attention to specific to the ray. All right, what about a line segment?
Yeah.
All right. How do I use notation? Just a flat line on top of it. There are several others you guys could have done, DF, EH. All right, what about a pair of opposite rays? There's only one answer for this one. Say it one more time. DE and EF? Okay. ED and what? EF. Good. You have to use the common endpoint as the first letter when you guys are naming them. Is everybody okay with that? Notations and naming and all that? Alright, next we're going to talk about angles. There are 3 different ways that you guys can name angles. It all depends on what's given to you in the picture. If the only thing that they've labeled is the vertex, then you just use that letter. So if you don't see anything else in the picture, you have that one angle, you only have that there, then you would just call it angle D or whatever the letter is. Okay? However, if you have this going on, if I said angle E, would you know which one I'm referring to? No. So you could have the full angle, you could have the upper part, the lower part. You can't just use one letter. Okay? So we use a 3-letter system here, where you go from the top to the vertex and then out again. Right? So if I want to talk about this angle right here, shade that in so you guys know which one I'm referring to. How would I name that angle? D, E, F. Vertex should be in the middle. The other 2 letters, the other 2 ends of the rays are on the outside part. Now, could I also call it FED?
Yes.
Yes, you could. All right, either of those are valid. And then if they use numbers, you just call it angle 1, whatever number is kind of tucked into the vertex, use that. All right, so for this example right here, what are 2 other names for angle 1?
Y.
No, you cannot use Y. Because if you say angle Y, it could be this angle, it could be that angle, it could be this one, that one. You can't just use one letter.
Angle X1.
I heard angle XYW, which is correct. There's another one. Yes? Yes. WYX. You can go in either direction. You can go from X to Y to W, or from W to Y to X. Either direction, left to right or right to left. What about for angle 2? WYZ or ZYW. Alright, so not only do you guys need to know how to name angles when you're looking at a diagram, you also need to know what angle I'm referring to when I give you the name. Right? So what we're going to do in this last activity here is I'm going to come up with maybe 2 angles, and then you guys are going to come up with a couple. We're going to find them on this picture, and we're going to figure out whether they're acute, obtuse, right, or straight. Right? So the first one I want you guys to look at is angle EFC. EFC. Find it. You guys see where it is? You start at E, you go to F, and then you go out to C. What kind of angle is that? Obtuse. All right. I'll come up with another one. How about angle BFD? Where is it? BFD. Do you guys see it in the picture?
Yeah.
You start at B, you go down to F, and then out to D. It looks like this right here. How am I supposed to tell if that's acute, obtuse, or right? The numbers, right? We're used to counting or measuring angles starting at 0 and then going either direction. This one's tilted, right? So how am I supposed to figure out what the measure of this angle is?
You can see it goes through, I think it's like it could be like 158.
Okay, so you're saying this is 158?
Yeah.
This angle right here?
Yeah. Right. Those three.
This angle is 158 degrees.
No, I'm not saying that. I'm saying like,
So it goes through this little thing.
yeah,
right here.
and then it goes through 50, so you subtract 50.
50 from the
Yeah.
one, I don't even know. What is
No,
that?
148.
148. You guys see how we have different markings on the protractor? So this one is approximately 148. This one's approximately 50. You want to find those two markings. Alternatively, you guys could have done 32 and... What's the other number? 130? You could have picked those two as well. Why? Okay. Pick either of those, whether you want to go left or right, doesn't matter, but then how to actually find the measure of the angle. Subtract. So what's the measure of that angle? So it's acute, obtuse, or right. Alright, I need 3 more volunteers to make up an angle, and we're going to figure out some information about it. Yes. Alright, everybody. Oh my goodness. Well, I don't know why it's doing that. Nope. What was it again? AFB? Alright, everybody find AFB. What kind of angle is that? Acute. It's approximately 32 degrees. Alright, one. So that's another angle that we could look at. Yes. CF, which one? D. Okay, CFD. What do you guys think? I need proof. This would be 115 if we're using the same scheme as the previous one. And then if you subtract those, would you get a number less than 90? So is that acute or obtuse? Okay. Can somebody name the straight angle in the picture? Yeah, me? Or EF. Okay. And again, we really don't use straight angles that often, so they probably just refer to it as line AE or EA. You pick. You decide whether you want to use the top or the bottom, going this way or that way, and then you just stick with that. But if you're measuring the angle, like see how from here to here it's acute, you would have to use the small numbers to measure that. But when you're trying to figure out between the two to subtract them, you just pick whether you want to use the high end on this side or that side. You choose. You'll get the same answer either way.
You have to do high end on both or high end.
It has to be high level. So if you're doing that subtraction method over here, you'd have to pick the high end on the left and the low end of the right, or vice versa. Alright, everybody okay with notation? Knowing the notation for line, segment, ray, angle. Knowing how to name things appropriately, especially planes and points. Yeah. How many points do you need to make a plane? 3. How many letters do you use to name a point? 1. How many letters do you use to name a segment, line, or ray? 2. If you don't have a symbol above the 2 letters, what does that mean?
It's
The measure of that segment. Or you made a mistake and left off a symbol, but if the directions specifically don't have that symbol there, it means measure of the segment. Alright? Everybody good? Done? Okay, you guys are free to relax. The homework, we're not going to have anything to do next class because we just finished everything. So if you want to leave the homework to do in class tomorrow, that's fine with me. But it will be due next A-Day, which is on Tuesday, because we do not have class on Monday. The homework would be the following page. Yes. The homework is the following page, and you're expected to do all the questions. Okay? I prefer that you not. Does anyone have anything to do in class? Yes.